Welcome back to the Microlearning Credential on Effective Healthcare Waste Management. This is Module 4 of the course. In the previous lessons of this module, we studied waste reduction and segregation. In this final lesson, we will study various mechanisms for waste treatment and disposal. This is the final lesson for Safia before she can start handling and managing waste on her own. Uma begins the lesson. The purpose of waste treatment is to reduce the potential hazard posed by healthcare waste, while protecting the environment. Treatment should be viewed in the context of the waste management hierarchy, where measures must be followed to reduce and reuse waste items, followed by their treatment to reduce their volume and potential health or environmental hazard. Lastly, the remaining residues can be sent to landfills for disposal. Let's first understand the methods of waste treatment. Medical waste can be treated and disposed of in a variety of ways. Some are best suited to large facilities such as hospitals or centralized institutions, while others are better suited to low to middle-income countries, small facilities, and resource-constrained environment. The first stage in any waste management strategy is to reduce waste and correctly segregate it at the source. Once the waste is segregated, it is treated using different methods like incineration, autoclaves, chemical disinfection, microwave. These methods break down the waste into finer particles and sterilize them, making it fit for landfill disposal. The treatment of the healthcare waste using these methods can be classified into two broad categories: on-site treatment and off-site treatment. Let's understand these categories first before diving into the methods of treatment. On-site treatment and management require segregation of waste at the point of generation and on-site methods like autoclaving and thermal decomposition to treat the waste volume at source. This method helps in reducing the waste burden on municipal as well as healthcare waste management facilities and diminishes the cost of waste management. However, this method might not be suitable for complex waste types like radioactive waste, highly infectious waste materials, and for large quantities of waste streams as well. On-site treatment is only suitable for limited capacities due to restrictions of space availability. Off-site treatment includes transport of mixed waste collected from healthcare facilities to a central waste treatment plant where segregation and treatment of waste happens. Treatment includes robust chemical degradation methods and industrial type of incineration. Due to elongation of various steps in the waste supply chain, this method is costly, but well suited to large amounts of healthcare waste. Better segregation and treatment of the waste material is possible, because a specialized place is allotted for healthcare waste management. Now let's look into each of the treatment methods. Medical waste incineration involves the burning of waste produced by hospitals, veterinary facilities, and medical research facilities. These wastes include both infectious medical waste, such as used syringes and needles, used swabs, plasters and bandages, as well as non-infectious, general housekeeping waste. Incineration is a high temperature, between 590 degrees Celsius and 650 degrees Celsius, dry oxidation process that diminishes organic and combustible waste to inorganic, incombustible matter and results in a significant reduction of waste volume and mass. The resulting solid ash can be disposed of by traditional methods, such as landfilling. The disadvantage of incineration is the release of combustion byproducts into the atmosphere and ecosystems. Burning of harmful chemicals releases ash in the surrounding that can cause lung disease, heart disease, neurological disease, cancer and other health problems among health workers. Autoclaves are enclosed chambers that sanitize medical equipment by applying heat, pressure, and steam over time. Autoclaves have been used to sanitize medical devices for reuse for over a century. Surgical knives and clamps, for example, are sterilized in autoclaves. One issue with autoclaves is that the process might aerosolize compounds present in the trash, resulting in the discharge of items that ideally should not be released. Chemical disinfection destroys bacteria in medical waste and can oxidize dangerous chemical substances, primarily by the use of chlorine compounds. For years, chlorine bleach has been utilized in disinfection operations. It's used to disinfect and sterilize reusable materials and equipment. It is too expensive to utilize on landfill-bound equipment or waste. Microwave radiation is used to treat sludge from wastewater treatment and as a heat source for medical waste treatment. On-site microwave treatment equipment and transportable treatment trucks are both options for this method. Only when there is water in the waste can microwave disinfection work because the radiation operates directly on the water, not the solid waste components. As a result, humidifiers are frequently included with treatment units. Microwave treatment of medical waste is less expensive than burning, albeit it does not chemically modify hazardous materials like incineration does. Now, let us look at the waste disposal methods, which is the final step of this process. Landfills are used for the final disposal of all waste. After minimization, all waste systems dispose off their waste streams to land for final disposal. It includes uncontrolled and controlled dumping, encapsulation, energization. Let's understand them one by one. In less developed areas or less equipped healthcare facilities, direct use of landfill might be done. There can be two ways of land disposal of waste: uncontrolled and controlled dumping. Uncontrolled dumping is characterized by scattered and unruly deposit of waste without their containment. Controlled landfilling represents disposal into the land characterized by better operating practices and design improvements to reduce health and environmental impacts. It can be done by isolating hazardous biomedical waste from the environment. When the disposal of waste needs to be done in a landfill, the waste should be contained in some way before disposal. This can be done by encapsulation, which includes filling containers made of high-density polyethylene or metallic drums with waste, adding an immobilizing material like plastic foam, and sealing. After the medium has dried, the containers are sealed and placed in landfill sites. Encapsulation alone is not recommended for non-sharps waste, but may be used in combination with treatment of such waste. Another waste disposal process called energization involves mixing waste with inert substances such as cement, rubble, clay, etc., before disposal to minimize the risk of toxic substances reacting and leaching into surface water or groundwater. For the energization of pharmaceutical waste, the packaging is removed, the pharmaceuticals are grinded, and a mixture of water, lime and cement is added. A homogeneous mass like solid cubes, pellets or liquid sludge of the mixture is then produced on site. Finally, these are transported off for landfilling. Safia and Uma decided to meet after lunch to discuss the treatment and disposal methods according to waste category.